All right, and so we do the division, and we come up with 8 kilometers per hour, right?
Right.
Okay. Okay. So
Okay, and that's the which.
that's our answer, 8 kilometers per hour.
Okay.
All right. Okay. I'm going to read through this question, and I want you to tell me whether you think it's a round trip question or not. A passenger plane made a trip to Las Vegas and back. Pretty much that's the clue, right?
Exactly.
Okay. So immediately, this is how I want you to approach this. When you say, okay, round trip, RT equals RT. Because when you look at a distance, rate, and time problem, you're trying to ask if it's a basic one or is it a round trip one? Is it simply ask you for, hey, what's the distance, how far, or how long is it going to get there, or how fast is the vehicle going? When I look at that and I see Las Vegas and back, that indicates that it is a round trip. So the round trip formula is RT equals RT. From this point, what I'm going to do at this point is I'm searching for clues, because that's all word problems are. It's like an investigation, all right? But we have our basic template that we're going to work with, right? So on the trip there, it flew 432 miles per hour. And on the return trip, it went 480. So what am I going to do with that 432 and the 480?
Well, they would go in different places, but when it says on the trip there, it flew 432 miles an hour, it would go where the rate goes on the left-hand side.
Mm-hmm. What goes there, 432 or 480 on the left?
432.
Very good. 432. And I'll put my equal sign here because I still have other things that I need to fill out. Continue. What about the 480?
On the round trip, it went 480. So 480 would go on the opposite side where the rate is.
Mm-hmm. 480.
How long did it take for the trip there? What? How long did the trip there take if the round trip took 9 hours?
The return trip.
Return trip, yes.
So what do we do with that sentence?
I'm thinking you'd have to plug in the 9 hours on the right-hand side.
Absolutely. 9 hours. Okay. Now, before that, they asked the question. What was the question?
How long did the trip there take?
Pause. Is that the unknown?
Yes.
Bang. There we go. So now we have all our information. We had our base formula. As we read through the question, we understood it was a round trip. We identified our rate, our unknown time on the trip there, and our rate and time on the trip back, which is known. So basically, 432x equals 480 times 9. I'll put that in parentheses. Okay, so what's our next move?
You would have to multiply 480 times 9.
Mm-hmm. But I don't want you to multiply 480 times 9. I'm going to show you how to do it quicker. Or, you know what? No, I'll do another situation. Let's say if I had 440 times 2. I'm not going to do this. I'm going to multiply 44 times 2, and then I'm going to add the 0 later. You follow me?
Yes.
Okay. So when that 0 is floating up there, that's one less step I need to make. I know that the 0 is going to be at the end. 44 times 2 is 88, 880, and I'm done with that, right? So what would you do in this case?
I'm not sure, really, to be honest with you.
Okay. I just gave you an example. We're multiplying 440 times 2. just temporarily don't work with the zero. Just throw it to the side here and just multiply 44 times 2. When we get 88, our answer is 880. So what would we do with 480 times 9?
You'd have to do 48 times 9.
Very good. 48 times 9. And we add the 0 later. So let's do the math. 8 times 9 is what, sir?
8 times 9. Oh man, I'm terrible at these.
It's fine. That's why I gave you a multiplication table. Use it. And don't worry.
It's 72.
72. So we drop our 2. 37. 4 times 9.
4 times 10 is 44. 36.
36. And then we add 7, which gives us 43. So our answer is 4,320. So we take our 4,320 and then 432x. Now the beauty of this question is, what is the difference between these two numbers?
Just a 0.
Just a 0. So something was multiplied by 432, and the result is 432.0. What does that tell you? This was multiplied by what?
100.
No, because if it was 100, it would be 43200. Only 1 0. So it's multiplied by what?
By 10.
By 10. So our answer is 10. Now, after we solve for a variable, we have to ask ourselves, did we answer the question? And the question is, how long did the trip there take? If the return trip is 9 hours, did we answer the question when we answered 10 hours?
Yes.
Okay, that's our answer. Okay, so now what I want you to do is tell me what we did start to finish.
Okay. First thing to identify is, like you said, if it's a round trip formula.
And what in that question told you that this is a round trip question?
The first sentence, actually, when they say a passenger plane made a trip to Las Vegas and back.
Good. Now, once you identify, hey, this is a round trip question, what are you going to do? Or what formula are you going to use?
RT equals RT.
RT equals RT. Bang, there it is. Okay. And at this point, we're just plugging in information, right?
Yes, exactly.
Okay, now read the next sentence and tell me what information you're going to pull out of that sentence to apply to your formula.
Okay. So they state on the trip there, it flew 432 miles, and on the return trip, it went 480 miles per hour.
Now, what information is going where?
The 432 would go on the left-hand side under rate.
Check.
And the 480 miles per hour would go under the right-hand side under rate.
Outstanding. Keep going.
And then they ask, how long did the trip take there? Which they don't tell us what that is. They're basically asking us. So that'd be an unknown variable under time on the left-hand side.
Mm-hmm.
And then they mention if the return trip took 9 hours. So that would go under time on the right-hand side.
Mm-hmm.
And then it's pretty much, it's really similar to actually a multi-step equation.
Mm-hmm.
Then you just multiply them at this point. So you do 432 times x, and then you drop everything down. And then you do you get rid of the zero for 480, and then you do 480 times 9, which came to 4,320. And you mentioned that we had to multiply 432 times 10 to equal 4,320, right?
Yes, sir.
Okay.
Okay, so our answer's 10 hours, and then at the end of, after we solve for X, we ask ourselves, did we answer the question?
Right, and they're asking how long did the trip there take? And then we came up with 10 hours.
Good job. That's it, we're done.
Cool.
All right. Now, sometimes some problems have a lot of moving parts. A cattle train left Miami, traveled towards New York. 14 hours later, a diesel train left, traveling at 45 kilometers per hour in an effort to catch up to the cattle train. After traveling for 4 hours, the diesel train finally caught up, and they're asking, what is the cattle train's average speed? Now, when I run into questions like this, what I do is I label the hell out of everything. I just do, because it's a lot of words, a lot of stuff going on, and I don't want to get lost in the sauce, so to speak. So, how many vehicles do we have in this case?
So you have a cattle train that left Miami.
We have a cattle train.
Then 14 hours later, a diesel train left.
And we have a diesel train. Now, like I said, there's a lot of moving parts here. And what I'm going to do is I'm going to DRT, which is distance, rate, and time, and distance, rate, and time. I'm going to track, and let me put my MIA to NYC, arrow, northeasterly direction. All right. Now, I'm going to look, as I flow through this question, I'm going to look for the distance, rate, and time. I'm going to look for the distance, rate, and time as I read through this. Okay, so my phrase for word problems is read every line and diagram, or I say line by line and diagram. So, let's get to it. All right, so a cattle train did what?
It left Miami and it was traveling towards New York.
Okay, so I have that indicated. All right, 14 hours later, what happened?
14 hours later, a diesel train left, traveling 45 kilometers an hour.
In an effort.
In an effort to catch up to the cattle train.
Okay, now when you see 14 hours later, 3 hours later, okay, this guy left first. So we'll just put a number 1 over him. This guy left first. When you hear 3 hours later, you hear 14 hours later, you hear 5 hours later. Whose time does that belong to?
It belonged to the train that left first.
Very good. So I'm going to put 14 plus, which indicates we have to add more time to this guy. All right. Now, it says the diesel train left at 45 kilometers per hour. Whose rate does that go to? The cattle train or the diesel train?
The diesel train.
Very good. I'm going to put 45 there. In effort to catch up. So then what's the next sentence say?
After traveling for 4 hours, the diesel train finally caught up.
Who does that 4 hours belong to of time?
The diesel train?
Actually, it belongs to them both. So you give the diesel train a 4 and you give the cattle train a 4. Do you understand why? Do you see why? And if you don't, I'll explain it. It's okay.
No, I think my video is lagging for a second.
Okay,
So you do
the
plus
question,
4.
yeah, the question was, do you understand why both of these both vehicles are going to be assigned 4 hours?
Mr. Sheldon, for 4 hours, the diesel train finally caught up. 14 hours later, the diesel train left. Are we just adding up all the time that the question gives us?
My question is, do you understand why I put 4 hours of time on both vehicles?
I don't think so.
Okay. The cattle train left first. 14 hours. Now they're both traveling towards New York City. So 14 hours later, the diesel train left. Okay, this cattle train had been rolling the whole time and continuing to roll. 4 hours later, the diesel train catches up. So this 14 hours later, this guy didn't just stop. He was still rolling.
Okay.
So that's why we assigned an additional 4 hours of time to him.
Okay.
So this is why this guy's rolled 18 hours. So my question was, do you understand why I just didn't put the 4 in the diesel train? I'll put it on the cattle train as well.
Right. Now I get it.
Okay, great. You get it now. So the time here is 18 hours, and this guy is 4. We good there?
Yes.
Okay. Now, the beautiful thing about the distance, rate, and time puzzle is if we have 2 pieces, we can always find a third. All right. So based on what we have here so far, can we add any additional information based on what we've been given?
I don't think so, because they just asked the question at this point. What was the cattle train's average speed?
Okay. What is distance equal to?
Rate times time?
Rate times time. Very good. So if we have a rate and a time, can we find the distance?
Yes.
Okay. Do you see a rate and time for the cattle train or the diesel train?
I see it for the diesel train.
So we can find the distance, can't we?
Yes.
Okay. What are we going to multiply to find the distance?
45 times 4.
45 times 4. Very good. Tell me what your answer is when you get it, sir.
I got 180.
180. Very good. 180. Now, if the diesel train caught the cattle train and it ran 180 kilometers, how many hours has the cattle train rolled before it was caught?
So it caught it at 18 hours in. After leaving the station in Miami.
Okay. Let me put it to you another way. If you and I leave your house first, and you say, "Hey, Keno, I'm gonna catch up to you later," right? And I make it to the highway. You left 10 minutes after me, and you finally caught up to me at the highway. Isn't it safe to say that we traveled the same distance?
Yes.
So if the diesel train ran 180 kilometers, what do you think about the cattle train?
Would it make sense to have it the same?
I'm sorry?
It would I'm not 100% sure on the answer.
I'm
Would
asking
still
you,
be-
how much distance do you think the cattle train moved in this question?
180.
180, very good. Again, if we have two parts of the distance, rate, and time problem, we can always find the third. So based on our distance and our time, can we find the rate of the cattle train?
Yes, we should be able to by doing rate equals distance over time.
Okay, that would be your formula.
Divided by 18.
So we have 180 divided by 18.
Mhm.
What's the difference in these two numbers?
Just to 0.
So 18 must have been multiplied by what?
10.
That's your answer.
Boom.
10 kilometers per hour. And then at the end, you have to ask yourself, did we answer the question? Because in some cases, just because we found X does not mean we found the answer to the question. We just found the variable. All right?
Mm-hmm.
Okay.
All right.
The next question, and I'm going to demonstrate, is what we call a delayed departure. What did I say?
A delayed departure.
Very good, a delayed departure. Now, the delayed departure, or what I call a delayed departure, is a situation where one vehicle leaves first, and another one catches up. Now, number 2 was similar to delayed departure, but there were just so many moving parts to it. I just label everything like I told you, just to keep myself out of trouble. All right, so the formula is still going to be RT equals RT, but we won't put our little there and back arrows in there. So this is the delayed departure. Delayed at departure. All right, RT equals RT. So this is the mindset that I'm trying to get you into. When you look at a distance, rate, and time problem, the first thing is, okay, what type of distance, rate, and time problem is this? Does it fit a model that you and I have covered, right? And if it does fit the model, like when we say, okay, aircraft carrier made a trip to Guam and back, that's a round trip. A passenger plane made a trip to Las Vegas and back, that's a round trip. RT equals RT with the arrows, right? But in the delayed departure,
Right.
somebody leaves and somebody leaves an hour later or sometime later, driving in the same direction in an effort to catch up. And then, okay, finally Bob caught Stu 5 hours later or whatever. Okay, so the delayed departure is also RT and RT without the arrows. Okay, so we're going to be looking for a rate and a time equaling a rate and a time. All right, so I'll flow through this. Jose left the White House and drove toward a recycling plant at an average speed of 40 kilometers per hour. So this part is going to be Jose. This side is going to be Jose. And Rob is going to be on this side. So this is Jose's rate and time. This is Rob's rate and time. Good there?
Yes.
Okay. Now, he left at an average speed of 40 kilometers per hour. So this is Jose's 40 kilometers per hour. I'll put my equal sign and make room for my time, my rate. So everything just flows downward. Rob left sometime later, traveling in the same direction at an average speed of 48 kilometers per hour. So that is Rob's. Okay, so we have our rates knocked down, right?
Right.
Okay. After driving for 5 hours, Rob caught up. Whose 5 hours does that belong to? Rob or Jose?
It would be for Rob.
Very good. That is Rob's. All right. Okay. So the question is what? I want you to tell me what the question is. Read.
After driving for 5 hours, Rob caught up to Jose. How long did Jose drive before Rob caught up?
How long did Jose drive before? So that's the unknown, right?
Right.
X. Okay. So this represents the time. How long did Jose drive? That's Jose. How long did Jose drive before Rob caught up?
Mhm.
Okay. So what's our next move? Now we have our R, our T, our R, and our T. What's our next move?
We would basically have to start doing out the problem. So you have to do 40 times x, which is 40x,
Mm-hmm.
which would be equal to 48 times 5.
Mm-hmm.
Then you have to figure out what 48 times 5 is.
Right.
48 times 5. 5 times 8 is 40. 5 times 4 is 20, 24. All right. So then you just drop it down to be 40x equals 240.
Now I'm going to show you another math trick. Most people will look at that and they'll be like, okay, well, 40 on the outside of the house and 240 on the inside of the house. Could you calculate that in 3 seconds?
No.
Okay. If I chop off an equal amount of zeros, I'll get the same answer. Can you calculate that in 3 seconds?
It doesn't go into 24.
4 doesn't go into 24?
Oh, I'm sorry. 4, 24. Just catching up. 40. So you would 24. All right. So it'd be 6 times.
Mm-hmm. You get the same answer. So what do you think was the easier math question? This one or this one? 24 divided by 4.
Definitely the smaller one.
Mm-hmm. So you can chop off an equal amount of zeros and you'll get the same answer. So x is equal to 6. Now we have to ask ourselves, did we answer the question?
And they were asking, how long did Jose drive before Rob caught up? So that's what we would be looking for, right?
Mm-hmm.
Okay.
So was that, you didn't answer my question. Did we answer the question?
I think so, but they mentioned.
You think so? You have to be positively sure. You can't. I think that's the question. That's not how we do this. All right. This is math. It's an exact science. Okay. What was X? What did X represent? What does X represent?
I'm sorry?
What does X represent?
The unknown variable.
Okay, what was the unknown variable? I like that, the unknown variable, Kino. All right, what is X positioned under?
Be under Jose's time.
Under Jose's time. Very good. So we found the X, didn't we?
Yes.
Okay. So when the question asks, how long did Jose drive before Rob caught up? Would that be Jose's time?
Yes, it would.
So we positively did answer the question.
Right. Yes.
Okay. You have to be sure about what you're doing here. That's why I give you the type of distance rate time problem. I give you the formula. I identify this is Jose's rate and time. This is Rob's rate and time. So when we get to the end, Jose's time is the unknown. So after we go through algebraically go through everything, okay, X is equal to 6 hours. That's Jose's time. Then we look at the question. How long did Jose drive before Rob caught up?
6 hours.
6 hours. So you got to be positively sure because you did all this work.
Right.
And so you don't want to do all this work and be like, I don't know what that is, man. Like,
Yeah.
I don't know if that's
man.
Rob's or Jose's and stuff like that. That's why we're here. All right.
Okay. And just so I know for sure, we don't have to, after we got rid of the zeros in the long division, we don't have to add the, we just keep it as is, right?
No, we don't add the zeros back when we do it in the division. No, sir.
Okay. Cool.
All right.